Hello students, our today's topic is factors affecting resistance, or you can say the physical quantities which affects the value of resistance of any material or conductor, you can say. Okay, the whole topic is based on an experimental approach you can say. It is not a theoretical concept. The whole topic is based on, whole is based on experimental approach. Whole is on the experimental basis. So just note it down. It has been experimentally observed that the resistance of wire, the resistance of any material depends on following factors. Here, the first one, the value of resistance of any conductor is always directly proportional to its length. Okay, its length. Experimentally, whole is done by experimentally. Yeah. That is, resistance is directly proportional to the length of the wire. The resistance of any material is always directly proportional to the length of the wire. Okay. The next one, second, the resistance of any material is always inversely proportional to its cross-sectional area. Suppose that the wire is of cylindrical shape. This is the length of the wire, and this circular portion is the cross-sectional area. The cross-section is circular. So let us suppose that this cross-sectional area is A. Okay. Okay, that's it. So resistance is always directly proportional to the length of the wire and is always inversely proportional to the cross-sectional area of the wire. Now, just note it down. Resistance. Note it down here. Resistance is inversely proportional to the cross-sectional area of wire or conductor. The mathematical relation is here. Okay. Third number, the resistance of any wire. Resistance of wire depends on its material. This is the third one. The resistance of wire always depends on the nature of material. You can say material. Okay. As an example, the resistance of copper wire is different in comparison to the resistance of aluminum wire. Yeah, resistance of nickel wire, resistance of iron, resistance of steel, and so on. Because material of all those substances are different. Okay, so resistance of the wire depends on the material also. It has been experimentally observed. On changing the material, resistance of the that material has will change. Okay. Next, the last one. This is the third one, and the last one is the resistance of any wire. You can say conductor depends on the temperature also. The temperature of the same wire. Okay. On increasing the temperature, the resistance of that wire increases. On increasing the temperature, the resistance of the wire increases. I am going to remove this. the fourth one I am going to write here. The resistance of any wire directly proportional to the temperature of the wire. Here T is the temperature. This much. In the statement you can say the resistance of any wire is directly proportional to its temperature. This is the fourth and last one. Okay, all these four physical quantities I mentioned here on which the resistance of any material or wire depends. Okay, the first one is length, second one is cross section area, the third one is the material of the wire. On changing the material, the resistance of wire changes, and the last one is the temperature. Okay, mention this as equation number 1, mention this as equation number 2, and mention this as equation number, not this relation as equation number 3. So since this length and cross sectional area are directly related with the shape of the wire, shape and size you can say. So on combining these two, on combining these two equations, we have a combined equation. Okay, just combine only these two equations in which length and cross sectional areas are there, which are directly connected to the shape and size of the wire. So only you have to combine this first equation and this the second equation. Okay, so just I am going to remove this. Combine equation 1 and 2. After combining equation 1 and equation 2, we get resistance is directly proportional to length upon cross sectional area, like this. Length is in the numerator and cross sectional area appears in the denominator. Okay, there is a mathematical rule again further. After removing this proportional sign, we have to insert an equal sign and a constant. This is a mathematical rule. Okay, rule of proportionality. So equal to and a constant, and all the other physical quantities remains unaffected. If you remove the proportional sign and insert an equal sign and a constant, so all the other physical quantities remains unaffected. So that constant, this constant have a symbol rho, like this. Okay, so this is a Greek symbol. The symbol is called rho. Mentioned as RH. This is a constant. So this new constant is called the specific resistance or the resistivity of wire. This constant which appears here is called the specific resistance of wire or resistivity you can say. Okay, and all the other things you already know. This is the length of the wire, cross sectional area, and resistance of the wire. So I am going to write down here. Here rho stands for specific resistance. Of wire. You can also say resistivity of wire. Okay. L here, L stands for length of the wire. And this A stands for cross sectional area of the wire. Cross sectional area of the wire. Okay, R, here R stands for resistance of wire. wire. That's it. Okay, this relation you have to learn this. Very useful for you for the numericals and other conceptual questions, assertion, reason and case study based question also. Okay, this R equals to rho into L upon E. Here there is a new constant which is called resistivity of the wire. Now we are going to discuss what is the meaning of this resistivity and what is the difference between resistivity and resistance. Matlab our next target is the definition of resistivity. So just note it down. What is the basic definition of this resistivity and how it is different from this actual resistance of the wire, and what are the similarities between resistivity and resistance of the wire. Okay, so this we are going to discuss. So just note it down. Resistivity. Resistivity. The symbol is rho, like this. The formula is here. R equals to rho L upon A. Just convert this relation as a formula of rho. You will get rho equals to R into A upon L, like this. Both the formulas are same actually. Both the formulas are same actually. Okay. Now we are going to define this resistivity in terms of resistance. But for that we have to assume this cross sectional area as unit as 1 and this length as unit means 1. 1 means you can say 1 meter, 1 centimeter. Okay. So this is a mathematical, you can say physical rule or mathematical rule for the definition of any constant physical quantities. Okay. So just assume cross sectional area as 1. You can say 1 meter square unit, and the length of the wire as 1 meter. Again this is also called unit. Unit means 1. Okay, after putting this all these values of unit 1 here and here, you will get resistivity as equals to R. Okay, if this, then you will get this. So resistivity does not equals to resistance always. There is some specific condition. The condition is there. If you assume a wire, suppose a wire whose length is 1 meter and cross sectional area is 1 meter square, then the resistance of this wire equals to the resistivity. Okay, so resistivity not always equals to the resistance of wire in some specific condition, some special case. The special case I mentioned here. Then in this specific condition, you can say in this special case, we are going to define the resistivity in terms of resistance. This is the rule. Okay. Now I am going to write and explain the definition of resistivity. Just note it down. Definition from here. Okay, so resistivity of any wire. The resistivity of any wire is the resistance of that wire of unit length and unit cross sectional area. Let me check. The resistivity of any wire is the resistance of that wire, कैसा wire, of unit length and the unit cross sectional area. ठीक है, okay. है ना? This is the actual and correct definition. Okay, so this is the definition of resistivity. It means that the resistivity of any wire is the resistance, normal resistance of that wire, कैसा wire? Of unit length, of length of 1 meter and unit cross sectional area. मतलब ये है कि किसी वायर का रेजिस्टिविटी उस वायर का रेजिस्टेंस के बराबर होगा. कैसा वायर? जिसका लेंथ 1 मीटर हो. सपोज दिस इज द वायर of 1 meter length and cross sectional area it is very must be equals to 1 meter square. If you measure the resistance of this type of wire, you will get the resistivity of the same wire also. Okay, overall the resistivity actually does not depends on the amount, because it is, the definition is bounded for 1 meter length and 1 meter square cross sectional area. That's why it is very clear the resistivity of any wire does not depends on length and cross sectional area. It only depends on the material of the wire and temperature little bit. Okay, so overall फिर भी resistivity is not a material property. Okay, it is not a material property because it depends on temperature also. Done. Now formula I mentioned here, this is the formula of resistivity. Now unit we derived from the formula. So rho is equal to R A upon L. Now, so the unit of this resistance is ohm. This area is meter square and this length is meter. Just cut this 1 meter and 1 meter from the numerator and denominator. So you will get ohm into meter. The unit of resistivity is ohm meter. Okay, done. Okay, this is for all today. Let further we discuss in the other video lecture. Thank you.